In this video, we want to graph the linear inequality x plus 4y is less than 4. And just so you know, this particular problem, the way it's worded, it kind of is telling you how to approach the problem because it's using the word graph and you have a grid staring at you. But there are many times where you will see the word solve instead of graph. You might see a problem that says solve the linear inequality. And then you have to know that graphing is the method, the only method, for solving an inequality that looks like this. And that is because what we have here is we have x and y, okay? And we also have an inequality, which means we're searching for all of the x and y values, which means all of the ordered pairs, x comma y, all of the points that will make this inequality true. So we want every x and y value, every pair, that when I substitute them into this inequality, I'm going to get a result that's less than 4. And there are an infinite number of points. There are an infinite number of x and y values that will make this inequality true, which means we have to graph it because we're going to shade where the infinite solutions lie. So whether your problem says solve or graph, same thing, really. If they tell you to solve the inequality, you just have to realize that you need to graph it and then shade where all of the solutions basically live. So in this case, I'm going to ignore the inequality temporarily, change it to an equal sign so that I can work on graphing this. And this is a line. It is always probably easiest to graph lines if they are in slope-intercept form. So I'm going to go ahead and subtract x. I'm working to get y by itself. I want to isolate y. And I'm going to divide both sides by 4 so that I will end up with y is equal to negative x over 4 plus 1. Now remember, negative x over 4 is really negative 1x over 4. So it would probably be easier if we wrote that as negative 1/4 x plus 1. So this is a line in slope-intercept form. We can see that our slope here is negative 1/4 and our y-intercept is positive 1. So we're going to go to positive 1 on the y-axis. And then since our slope is negative 1 over 4, that negative 1 is telling us to go down 1, and positive 4 means right 4. So if I go down 1 and right 4, I have another coordinate, and I repeat that, down 1, right 4. There we go. However, I could also move that negative so it's in the denominator. So that would be 1 over negative 4, which would mean we'd be going up 1, and then the negative 4 causes us to go left 4. So that would allow us from the y-intercept to go up 1 and left 4 and get some additional points on the graph. Now, before we connect the dots and make this a solid line, we need to consider the inequality sign. So we have a less than symbol here. This is not less than or equal to, which means we're not wanting all of the points on the line, but rather we're going to either choose all of the points that are above this line or below this line. We do not want to include the points that are on the line. So that less than sign is going to cause us to make this a dotted line. So just do your best to make this dotted or dashed rather than solid. If it is going to be less than or greater than, then you will always have a dotted graph. If it is less than or equal to, greater than or equal to, is when you will use a solid line. Then, as I said before, there are an infinite number of solutions, so we just need to determine whether or not the solutions lie here above this line, or perhaps the solutions lie below the line, down here. To determine where the solutions lie, I think it is easiest to test a point. So you're going to pick a point to test. You can pick any point on the coordinate plane except for the points that actually lie right on the line. So I like to choose easy points, which in this case, I think 0, 0 is a pretty easy point to choose because 0 is a nice, easy number to plug in for x and y. So we're going to test 0, 0. And by testing, what I mean is we are basically taking the original inequality, x plus 4y is less than 4, and we're going to substitute 0 for x, 0 for y, and then we're wondering, question mark, if that will give me a value that is less than 4. So I put a little question mark on top of my inequality because I'm wondering if I have a value that is less than 4. In this case, I end up with 0 is less than 4, which is a true statement. 0 is a value smaller than 4. So what that means is that my test point, 0, 0, it is a solution to the inequality. So if you get a value or a coordinate, I should say, that is a solution, then that means that you want to shade wherever that coordinate is. So in this case, the coordinate 0, 0 is below this line, and that means that every single ordered pair, every x, y pair down here below the line will be a solution to the inequality. So if you choose a test point and your test point gives you a true statement, it works, then you want to shade wherever that test point is. In our case, 0, 0 was below the line. That's why I'm shading below the line. If we get a false statement, which would have meant that 0, 0 is not a solution, then you would just shade on the other side of the line.